Okie dokies, artichokes, let's get started. So today we are going to be talking about functions. Now you have actually been seeing functions a lot. You just didn't realize it because you don't know what that word means. That's kind of the theme of this chapter. You see it a lot, but you don't know the word. Anyway, functions show up a lot on the ISATs and you're supposed to be able to identify them and understand what the word means. So let's talk about what a function is. The specific definition of a function is any graph or equation for which when I put one x in, I only get one y out. Now, most of the equations we use, like y equals 4x plus 1, for instance, is a function. There is a little diagram that we like to use. It is called a function machine. So you draw this little machine here. If I was to put an equation like 4x plus 1 in here, I would stick x's in the top and y's would come out the bottom. Okay. You might also have heard this kind of as evaluating. So let's take a random number. I'm thinking, let's do 3. Okay, if I stick a 3 in, then I'm going to replace my x with 3. 4 times 3 is 12, plus 1 is 13. So I stick an x equals 3 in, and what I pop out is a y equals 13. This is a function because no matter how or what number I stick in for x, I will always just get one y response out. Same goes for something like y equals x squared. We've seen these guys a couple times. If we do a function machine for this, let me draw my little machine. Then whatever I stick in, I should only get one out. So let's come up with a random number. Let's do 5. So we're going to stick 5, oops, sorry, really blurry. There we go. We're going to stick 5 in, and we're going to see what comes out. So if we stick 5 in for x, then we replace x with 5. So 5 times 5, or 5 squared, is 25. So what pops out the y side is 25. Now the cool thing about x squareds is if I stuck in a negative 5, I would also get 25 out. It's kind of cool because a negative times a negative makes a positive. But because each x value has a single y value, it's still a function. Now what's not a function is if I stick in, so we'll draw a really quick one, the little function machine. If I stick an x in and then 2 y's come out, it's not a function. Okay, and I'm going to teach you how to identify that on graphs. But for the most part, if you take an equation and you put one value in for x, and then all of a sudden you have 2 numbers as the answer, it's not a function. Okay? So the main defining feature of a function is, can I stick one number in and get one number out? Okay, graphs. Graphs are probably one of the easiest places to identify a function. You guys are very familiar with the idea of a linear line. Okay, that is a positive linear line. You've also seen a couple parabolas. And in chapter 8, we're going to take a look at some exponential functions. Let's take a look at some fun ones too. So this is a parabola that's been turned on its side. This is a circle. You can graph those pre-calculus. And then when we get into polar coordinates, we can do fun stuff like that, which can make cool little flowers and butterflies. They are awesome. Okay, so there's something called the vertical line test when figuring out what's a function. So vertical line test. which basically says if I can draw a vertical line through any point of the graph and my line crosses what's been graphed twice, then it's not a function. So for instance, let's draw a line through this guy. How many times did I pass through that line with my brown line? Once. I only crossed it once, meaning this is a function. Okay, let's do that again. Let's draw a vertical line through my parabola. I only crossed it once. Now you might be thinking, but what if you drew it over here? What if you drew it over here? Doesn't matter where I draw the line. Oh, we're blurry again. Focus, focus. I will only ever cross through my parabola once, making my parabola a function. Okay, let's take a look at our exponential. Draw a line, draw a line, draw as many lines as you want. No matter how many lines you draw, you will only cross the function, or the exponential graph, once, making it a function. So here comes the interesting part. Let's take our sideways parabola. If I draw a line through it, how many times did I cross through my sideways parabola? Twice. And because I crossed through it twice, it's not a function. And the reason it's not a function is because let's say that, let me get a nice tiny pen. Let's say that this is x equals 2. Okay? Well, at the line x equals 2, remember if we find coordinates, we go over and then we go up to the line. Okay? So this is 2, let's say 2. 2, 2. But the problem is, on the same line, I also have 2, negative 2. Meaning that for my single x, I produced 2 y's. So it's not a function. Okay? Let's try it again. On my circle, let's draw a line through. Oh, I've crossed through twice, meaning this isn't a function. And no matter how I draw the line, I will always cross through my circle twice. So it's not a function. Okay, one last time for our little polar right here. Draw a line through. I crossed through it twice. It's not a function. And it's that easy. That's all you're going to do today. You are just going to look at different sets of functions to see, is it a function? So the very last thing I want you guys to look at before I let you go off to do your own craziness is we're going to look at a set of coordinates. Bam! Coordinates. Okay, so these are two sets of coordinates, and we're going to look at this and we're going to see which of them makes a function. So if we look at this guy, that's our first one, these are your x values, the very first number in the coordinates. So right now I have the x value 0, 1, 2, 1, 1. Okay, so I'm going to write this off to the side. 0, 1, and 2. My 1 appears 3 times. These are your y coordinates. So I have 1, 2, negative 2, 3, and 4. Don't try to plot these coordinates. They're going to make some kind of nonsense graph. They're just here to show you if what they made is a function. So what you're going to do is you're then going to draw a line to the y coordinate that the x matches, right? So 0, its y coordinate's 1, so I drew a line to 1. So 1, its y coordinate is 2. 2, its y coordinate is negative 2. 1 has another one at 3 and another one at 4. Is this a function? No, it's not a function because the 1x here, so 1, goes to 3 different y values, making it not a function. Let's do this one more time. So we have 0 as an x, 1, 2, 3, and 4. So we're going to write those off to here. 0, 1, 2, 3, 4. And now I have as y 1, 2, 4, 9, 15. Again, don't graph this, it makes nonsense. So we're going to do 1, 2, 4, 9, 15. And then we're going to draw a line. So 0 goes to 1, 1 goes to 2, 2 goes to 4, 3 goes to 9, and 4 goes to 15. If I were to graph this nonsense, would it make a function? Yes, it would. Even if it looks totally weird and is a super squiggle line, it would make a function, because if I was to draw a vertical line through it, it would only pass through once because each of my x values only goes to one y value. Okay, I hope that made sense. If it does not make sense, feel free to look up a function and the definition on Google. There's a lot of great resources, or just ask me and we can work through that. Today's going to be really easy. You're just going to get a couple sets of coordinates, a couple graphs, and you're just going to tell me, is it a function? And that's it. Have a great day, everybody. And we'll see you in the next lesson. Goodbye.